Dear students, we have discussed about Turing machine and we also discussed various problems in Turing machines. As an extension of Turing machine, we are going to have few topics. What is that meaning? Whatever the work done by Turing machine, we are going to do the same work with some effectiveness. We'll discuss. Turing machines are the machine which accepts or rejects regular language, context-free language, and recursively enumerable language. There are two there, recursive language and recursively enumerable language. It is a very powerful machine which can solve any problem. We used to always say, if you can define an algorithm for a problem, then we can define the same algorithm in Turing machine. This setup we call it as a standard Turing machine. What is extension of the Turing machine? With some minor modification, we are going to extend the Turing machine. It is not to solve additional problems. It is not that in Turing machine I cannot solve the problem, so I am going for extension. No, sorry, it is not like that. Whatever the problem we are solving in a standard Turing machine, same only we can do in extension Turing machine, but computational time and complexity will be reduced. Two major techniques, one is multi-tape Turing machine, other one is non-deterministic Turing machine. We will discuss one by one. Extended Turing machine can solve a problem much faster than standard Turing machine. Remember, this is what I told 2 minutes before. It is not that extension Turing machine can solve some problem which cannot be solved by, no, not like that. Any problem can be solved in standard Turing machine. Dot. We use extension for betterment. A small recap of Turing machine definition. We are going to have 7 components as a tuple: Q, sigma, gamma, delta, Q naught, and blank and F. So they are the machines which accepts or rejects strings of characters represented by any languages. We have Q as set of finite states. We have sigma as set of input alphabets. We have gamma as set of tape symbols. What are the symbols available in the tape? Delta is nothing but the transition function. What is that particular transition function? One simple example I am saying. If it is 1 in the tape, you are replacing by Y and then you are going to move right side. The header is moving right side. The state is changing from Q0 to Q1. In general, your state Q0, Q1 is called Q. The symbol in the tape is called 1. Later it becomes Y, which is called gamma. You can move right as well as left, so L, L. This is the generalized statement of the transition function. Q0 is initial state. B is nothing but blank character. F is nothing but set of accepted final states. There may be many accepted final states, so it is called set of accepted final states. What is multi-tape Turing machine? It's also same as Turing machine I told, which have more number of tapes. Multi-tape is the same as standard Turing machine with many tapes. Each tape has its own head to write and read. And each and every tape works independently. Control unit takes care of each tape and control its operations. In general, I am going to represent n number of tapes. Usually 3 will be there. Sometimes 4 also will be there. In general, we are going to have n number of tapes. We can write the same multi-tape Turing machine with 7 tuples. What are that? The same story. And already we discussed everything just now. But the transition function is represented as how many number of alphabets in each tape, n number of tapes, how many number of alphabets in each tapes, that is n number of tapes, and in n number of tapes, that is in first tape moving right side, second tape moving right side, third tape moving left side, even sometimes stay is also available, we will discuss. This is the Turing machine, you know, the control unit. It takes the input and based on the read and write from the tape using the head, it may accept or reject. Now what is multi-tape Turing machine? Multi-tape Turing machine is not having one tape, it has many tape. I am showing one more tape. I am showing one more tape. So I have taken example with 3 tapes. It is having a single control unit which controls tape 1, tape 2, tape 3. Each and every tape will have its own head which can read independently, read as well as write. If this head is going right side, this head can go left side. If this head is replacing 0 by x, this head may replace b by x. Anything it can be possible. What is the transition function? Very complicated transition function for multi-tapes because we are having n number of tapes. I have mentioned for 3 tapes. The state is changing from Q0 to Q1. It's just an example. In tape 1, if 1 is there, you replace by U and move left side. In tape 2, if X is there, you replace by V and move right side. In tape 3, if A is there, you replace by W and don't move left or right, you just stay. Even that concept is also allowed. This is what I mentioned here. The state is changing from Q0 to Q1. 1 is replaced by U, X is replaced by V, and A is replaced by W. And you can have left, right as well as stay movement. All will work independently, which means if he is going left side, there is no rule that he should go right side. He can also go left side, he can also go right side, like that. There are some key features and operations of multi-tape Turing machine. They are multi-tapes and heads, that's just a features. Independent movement, just now I told, and transition function. What is multi-tape and heads? A multi-tape Turing machine have finite number of tapes. We call it as n tapes. In the diagram I have shown 3 tapes with 3 heads. That is n heads for read and write. Independent movement. What is that meaning? Each head can read its own symbol and write its own new symbol. It can do independently and move left side or right side independently of other heads. What do you mean by that? It doesn't depend on other heads. Each and every head have its own independent work in a single step. All 3 can do at the same step. What is transition function? Based on the inputs from all n heads, decides its next state, whether Q0 to Q1 or Q1 replaced by Q1 only. And some small description I told. Each tape has its own header. When header of tape 1 is moving right side, we can move header of tape 2 as well as tape 3 in left side. This model intuitively seems much more powerful than single tape because you can feel that, yes, obviously sir, if all 3 can do at the same time, it's powerful, you may feel, and you are right also. It is definitely powerful than a single tape, but any multi-tape machine, no matter how many tapes, remember, it can do whatever the work by single tape only with less computation time, which means single tape machine with more computation time, whereas multi-tape machine takes less computation time. That you should know. It doesn't mean that whatever the work by multi-tape machine, single tape cannot do. No, I am not trying to say. The work done by a single tape is also done by multi-tape, but its computation time will be less in multi-tape. Thus, multi-tape machines cannot calculate any special function what a standard Turing machine can do. It is not like that. Whatever the work by the standard Turing machine, multi-tape also can do the same work. With this, I would like to conclude extension of the Turing machine, and we will also discuss some more extension in next video. Thank you.